So thank you all for coming. Just to get a quick sampling, how many of you are actually at game studios now and working in game studios or in games in some way? Okay, we have a good number. And the rest of you, I assume, are doing really awesome business software. All right. All right, well, believe it or not, games use business software, so thank you. So first, hello, welcome. This is a disclaimer. This project is not indicative of any particular project at Blizzard, and I'm not representing Blizzard's code in any way. This is a project I did on my own, but just because it says Blizzard doesn't mean that it's something that we're doing internally. Yes?
I was thinking, is this like some of the, even though it's not an internal project at Blizzard, is this stuff that actually is kind of based on the philosophy at Blizzard, or are they still with C++98, etc.?
Okay. So the first question of the day goes to the gentleman over here who asked for whether or not this is indicative of some of the philosophies of Blizzard and whether or not we are using these techniques. For the games, I'm going to tell you that probably not. But what this is kind of a case study in that there's a lot of new features that came in with C++11. And some of you may groan like, oh, we got C++14 already. Well, some of those things aren't necessarily in some of the compilers that we're using. And we're using a lot of different machines and things like that. So we have to use kind of the common set. So C++11 is one of the things that is new in that a lot of the stuff was based upon C++98. So with that new feature set, what are some things that we've had to do on the game side on our own that we can now kind of leverage some of those C++11 things? About me, I've been a 12-plus year veteran. I actually ran into a guy that was younger than me and played one of my games that I made, so I feel really old. I have 10 or so titles that I've worked on and contributed to, and I haven't really gotten the chance to really specialize in one particular thing. A lot of people have specialized in either graphics or networking or AI or something like that. I basically was a Swiss Army knife. They threw at the code and said, fix it. So I've had to do a lot of different things. I've done AI, I've done rendering, I've done physics, and I've done resource systems and things like that. So I kind of got a little sampling of all things, but not super deep on one. So the project mentality, or the idea of this project is, well, the idea of the presentation is we are going to go through these things, which will highlight the idea of what is a game engine, some of the C++11 things that can help us, some of the standard things that are present that we can leverage today, as well as some things that would be nice to have. And a couple of those are currently in this process of getting submitted to the standard, but they're kind of neat things that as a game engine person we use a lot of. Then we'll have questions, and if there's time, we have some bonus material and a nifty bug that I fixed. All right, so number one, what's the project mentality here? I wanted to leverage mass concurrency based off of a lot of the talks that I've seen and kind of the feeling of everybody loves the cloud, and cloud architectures are potentially infinitely scalable. So leveraging that is a good win. I wanted to leverage the standard over any of my own stuff. So I did not try and pull anyone else's implementation of anything. I didn't try and use any third-party libraries, and I tried to stay away from making my own versions of things. Keep it simple. Stay away from the C-style patterns that have kind of been leveraged in games. Don't really focus on graphics because there's always someone that's specialized and is going to tell you that you did it slow. And what the idea of here is that I'm going to be trying to do the magic 60 frames per second, which is 16 milliseconds per frame of work. And then this is a really good tool for me to learn the new standard features, as well as get me involved in kind of where C++ is going. So what is a game engine? Game engines interface with hardware, APIs, such as the graphics system, sound, network, and input, and various other things. But essentially, that's its purpose. We also have things like data creation and data loading. We'll also do data interpretation and data presentation. So that's the graphics fancy layer. So this is why does the game engine not use the standard? Well, typically a lot of the game engines were started during the lull period, as explained in Bjarne's talk of C++98, and there were some features that weren't as fleshed out or use memory as effectively as we wanted. How many of you here saw Chandler's talk this morning? Okay, not enough of you saw that. Everyone go get the YouTube video, see it. That is what game companies do with their kind of underlying architectures for how they use memory, how they want to use arrays of things and stuff like that. So it was really cool to see that. And it's really neat to see that he does a really good job of presenting it. So that is a really good talk to go watch. The containers is one of the faux pas of games usually. And if you go watch Chandler's talk, you'll see some of the things that he's done within the compiler to show the power that you can get from not necessarily using by using the containers in a different way. C-string is one of those things that has kind of been looked at as a horrible thing. And it has its uses, but comparing strings and things like that in games is kind of slow. So we don't really use that at all. So that there's been a lot of kind of built up, I guess, grief against the standard because of some of these things. They're not necessarily fully founded, but some of them are just based upon implementations that the standard did. So right now there is actually a proposal for a flat container, which is more like a game usage structure that is being done by Sean and Middleditch and a few other people as a way to get some of the more game-friendly things as part of the standard. There's also the thing of the templates generating a whole bunch of code size. The video that's linked here, that the slides will be available for everyone, so look at it later. But it goes into how to remove some of the extra bloat that the templates would create. Typically, it's just specializing your classes for your particular use instead of being super generic. We also have this assertion mentality that our exceptions are not wanted. So in our system, a lot of the game companies just turn them off on their compiler completely. We don't really try and handle them at all. Maybe we have a high-level one at the very top of our game loop or at the very top of our main loop, but we don't really do anything with them. This limits us in that we can't really use third-party code, typically because the third-party code uses exceptions. Some third-party libraries use exceptions as control flow, which is worse. So please don't do that. And we also have immense teams of QA that we hire that is supposed to catch a lot of the common things. We also, nowadays, we leverage a lot of the patching, which is widely available for all kind of consoles, withstanding the GBA, which doesn't really have that. But in general, we take the mentality of, look, if the game crashes, it's unfortunate for our fans and our people that paid us, and we are going to try to do everything we can to limit their pain. But at the end of the day, it's not a moon rover. We can patch it, and if it's like 1% of 1% of our users, I'm sorry. The cost of actually the exception unrolling and things like that was gone into really great with that website. If you have a chance, go take a look at it. It's really helpful. Now, there are 2 proposals or 3 proposals now going through the standardization process that are about creating lightweight exceptions. So then that would give us the ability to use these third-party libraries that do throw exceptions in a more lightweight manner, which is very interesting. So we're looking at that. What else do we do? Well, not all games are created equal. There are different concerns for different games. So there are guys here from Creative Assembly, and they do Total War. Total War has several thousand units on the screen at once. That's a different concern than a game like Overwatch, which my company makes, where you're right up next to the character. So you don't necessarily need a super detailed eyeball map on Total War. But since you're right up next to the character on the FPS, you might. So there are different concerns there, different trade-offs. The same with open world versus level-based game. You can get a game like Inside that's a very level-based game, and so you have a very curated view of everything, and so detail can be added there in a curated way, which allows for some graphical optimizations that an open world game doesn't allow you, because the game can be looked at from any angle in any way, and probably someone's underneath the terrain looking at it too. They also have platform restrictions. So until recently, Xbox and PS3 kind of had their own world that they lived in. With the 360, it became more of a Windows type architecture, but PS3 had its own craziness with its cell processor and their processing units that were split off to the side, the SPUs. PC and Mac have had similar type things. I remember when Mac had a different processor than it does now, but now they kind of share the same processor, the Intel x86 architecture, which is great for us, which means that we can now assume some things and leverage some of that technology. The problem we also have is the PC has a lot of variance in hardware. You know, some people go out and buy new rigs for games, and they have very advanced graphics capabilities, but other people still are playing on Windows XP. And so we're supporting those people too, which makes it very difficult for you to kind of force someone to have the greatest and latest feature in the game or graphics technique, and then still support the people that are running XP. Mobile devices as well are more kind of a curated architecture where you have limited space that you can do things in, as well as some of the language features. So on iOS, there are certain things that you have to do through Objective-C, or you have to create interfaces from Objective-C to your code. And for Android, it's the Java version, where you have to do Java and then into your code. And then we have the web. So there's some guys here from Wargaming. Are any of y'all in here? So they have a really cool embedded 3D hardware accelerated thing in the web browser. It's not Flash. And depending on when they updated it, that might be leveraging other technology than HTML5. But there are concerns there that you would trade off. You wouldn't do the same thing that you would do in other things. All right, so how does C++11 help us? Well, if you remember the things that we had to deal with, our data creation and loading part, we can leverage this const expert thing. I know that this sounds kind of like a weird keyword, and at first it was weird to me, but after looking at it a while, I was like, man, you know what? We have a problem in games. So some coder implements something for our resourcing system, and he says, oh, it's reliant upon this particular version, version 1. So then another coder comes in, and he says, oh, actually, we need this other data. And he adds this data, or maybe he just moves some of the data around. And then he doesn't increment the version. At that point, he checks it in, everything goes to the asset people, and they're starting to do stuff, and they're like, hey, my game doesn't work. Well, at that point, you have a version problem. So typically when you track that down, you have to tell everybody, hey, get this old build. Or you have to yell at the guy and tell him to fix it, and then smack him and tell him, don't do that again. So with const-expr, since it's compile time, you can actually perform some operations on your code and generate a unique resource ID for all of your resource data structures for serialization and deserialization. You can also use static assert, which is new in C++11, for compile time checks, which is great. You can make sure things are of the size that you want. You can make sure that things are of the types that you want. It's great leveraged items. So let's go through with versioning this structure. This structure is a very simple structure. It's essentially just a spawn point that has position and a direction. And we have a small structure that's our vector, leveraging a new technique, which is initialization at declaration within a class, which is very useful. So what are some of the things that we would do to hash this? This is where you yell at me all the cool stuff. All right, so first what we'll do is we'll say, hey, the name of the structure has got to be unique, because you can't have two classes name the same thing. You'll get like duplicate declarations, and it'll get weird. All right, so we can do that. And then, oh, well, yeah, the data member types, those are unique. Potentially, if someone changes it, yeah, they'll change, but you want to know that that's a new version. So then you go, okay, well, the data member names, because we have a position and a direction, What happens if someone changes that direction to a quaternion instead of just a vector 3? That's something that's good for that. Or if we add a new position. We have data member order. Because what happens if someone swaps those? They say, hey, the direction is actually above the position for whatever reason. And we have one final thing, which is data alignment. So this one I don't go deep into, but we can do things, and we do things with data compacting to get our structures as small as possible, so when we're serializing them in and out, it goes really fast off the disk or off the RAM, so we can get them into the game as fast as possible. All right, so here's the code wall. What's it doing? So at the very top, you see I have that using keyword, which is kind of nice. That's a new feature as well. That one doesn't really impact a whole lot of things, except it gives us some things that we can reason about stuff. I also have this structure there that I'm calling constexprstring. And that is just something that I'm leveraging so then that I can pass in to my constexpr functions and know what the size of the string is, because it takes in a const string. All right, and then my first function there is a string hasher. It basically goes through my constexprstring structure, iterates through all of the items that are in there, and then calculates a hash. Well, I have some things where I have arrays of these constexprstrings, and that's the second function, which goes through and calls the constexprarray function and goes through for each one of the constexprstring structures and then hashes that and then totals it all together. Now, this is pretty cool because it generates a unique hash based on any of the structure layouts that you have, your data layout. So I didn't do a super advanced one, but I have a coworker that was excited by the possibilities of constexpra, and he implemented SHA-1 as well as MD5 hashing in constexpra. So that is amazing to me. The SHA-1 code token is a little bit bigger than what my hash value is. I'm only using a 32-bit int. He's using a much larger structure. But for my purposes, this got me what I needed. So what does that do? Well, I have 4 structures that are essentially a replication of that spawn point. But they're all different in some way, and they all generate a different hash code based on the code that we just looked at. So this is the magic, is I'm using the macros magic, which is starting to become faux pas. But essentially what I have here is I'm declaring these structures with these macros, and then in my compilation, I make passes on every one of these objects multiple times. One time I generate the hash. Another time I generate the actual structural definition, either a class or a structure. And then one time I actually go through and generate a list, an in-order list of all of the serialization or deserialize functions, which is important when you're serializing data in, so you unserialize the data in the right order. And I'm also using a trick a constexpr trick in there where I am figuring out the offset of the class to each data member. So instead of calling serialize or deserialize on a particular member, I'm just telling it like, hey, go to this offset in the memory and just splat down your information. And that works really well and really fast. But now I have a compile time changing data version check. So then all our tooling, that if we're doing tooling, can then check and see like, oh, did the data version change? I just regenerate the data. Hey, did the artist now pull a version that they don't have? You can throw up a warning, or you can throw up an error, or you can just have them start exporting it on their machine. And it kind of eases that pain of the, oh my God, we have to search, and why didn't this guy change the version number? So mass concurrency. It's not necessarily new to C++11, but it is coming in new in that the standard is now enabling certain things. So there is a standard thread now, which is really usable for that. And they have the standard mutex as well as the standard condition variable and other things, and then there's a static library or standard atomic library, which gives you those atomics, which we used to have to implement ourselves using, things, apparently. But we had to do it ourselves per platform, and we also had to do things if we were doing Xbox or PS4 or PlayStation. You had to do their specific implementations. But now it's in the standard, so then that everyone can kind of play nice. So for this, the quick benefits, I'm sure that everyone would see that, is it exploits the multiprocessors of the machine. The cloud-based processing can dynamically scale. The tasks can be small and simple, which allows you to focus optimization on those particular tasks instead of having to kind of look at everything as a whole. You can optimize a single task and get wins there. Serialized sequences can be distributed to multiple places. It's highly modular, so then that you can change different versions of tasks easily. So if you had one version and then you change a different version, you can then go back to the old version if you want to. I'm not saying we do that at runtime, but as you're iterating through the code, you can make those changes, and it's simple to kind of drop those in. Efficiency of doing multiple things at once can outweigh the serialization wins of cache coherency sometimes. All right, so what are the things that we have to worry about? Well, one thing is our tasks need to be as independent as possible. That makes it to where you really can't rely upon other tasks to do your own work. And that takes a little bit of thinking about how you're interacting with your data. Excuse me. As well as data manipulation needs to be thread safe. This is the deadlock or live lock situation. You need to keep in mind the when your data synchronization happens. Some people like to synchronize their data every time they change it, which then you're basically doing a serialized game, and that's not good. You need to take into account you need to take into account that things can happen in a non-deterministic order. So if you're expecting 6 things to happen in 1, 2, 3, 4, 5, 6, that may not happen because different threads may have grabbed it, and one thread finishes early and the other one doesn't pick it up yet and is now starting on it. So there are some things that you need to remember, is that if you kick off a bunch of tasks, you can't say like, oh, well, it's going to execute in this specific order. Your task queue speed is really going to come into play here. There's been some great talks about concurrency and task queues and how to do things with mutexes, as well as the lock-free method, which is so the mutex method is basically like a stoplight situation coming at an intersection. People stop, then the tasks go through, then that side stops, and then more tasks can go through the other direction. The lock-free method tries to eliminate as much of that as possible, and so it's more like an on-ramp situation for highways. And so then tasks are kind of just naturally moving into their execution lanes and things like that. And there is a concern of thread context switching. If you are just executing stuff without kind of taking consideration your thread context, you can invalidate your caches and have to go and have cache misses all over the place, and having to re-pull that data from out of the cache into the cache may degrade your performance gain. So with that said, let's create a simple task system. So I have a task system that I wrote for this example, and I'm not using a class. So typically, a lot of the game companies I've been at and a lot of the implementations I've seen have been more like a singleton class structure. And this is not that. The idea there is that what I want to do is I want to hide the implementation of my task queue, because everyone else doesn't need to care about what my task queue looks like. And if you're including things and you have this header and it includes a class and it references a class without forward declaration and all that, then you have to include what the task queue looks like to everyone else, all the other compilation modules. So instead of doing that, I abstract that, use a namespace, and this is essentially all the interface that I need. So this is how we add tasks. I essentially have a namespaced static task queue, and I push things onto it. And for the track task, I essentially create a wrapper around the task and then push that on there. And you'll notice a couple things for C++11 in that I'm using unique pointer and I'm using future. And I'm doing those as a way to allow for the concurrency for the future case, so I can get back information on when the task was completed. And the unique pointer is allowing for proper shutdown if, let's say, the game immediately needs to, if the user says, hey, I'm exiting the game state can immediately delete all the data that it needs to because the unique pointer goes out of scope, and then it can return it back to the memory pool, and then you can go back to your main menu, something like that. So this is to keep all my cleanup possible in case of a crash or things like that. It'll kind of clean up the data for me. I'm also using the move semantics to move stuff around. Unique pointer kind of forces you to do that, but this is to highlight that the move semantics are a very valid way of doing stuff, and I'm sure that everyone has seen the move semantic stuff. If you haven't, then there's more. Yes?
I was just wondering, I noticed that you have push on your task. Is that actually, is that just like a named feature, or are you using some sort of, is that an error? Because I don't think any of the standard library features have push.
Right. So right now, so the question was about the push that I have there. It was like, where does that come from? That's not a standard name for a function in any of the standard data structures. That is true. And the reason that is I have an abstraction that I'm using that is wrapping the standard functions. So this is just as simple of an interface as I needed for this particular thing. Essentially, we'll go into it more, but push essentially pushes one onto my queue, and then pop pulls one off the queue. So again, code wall, great. Now no one can read it. So I'm using several things here. So I have an atomic bool, which tells me whether or not I should run tasks. This function is what I give to all my threads. I have a thread pool that's that creates a unique pointer for a list of thread pools, or a list of threads. And then I allocate those by asking the computer at runtime, hey, what is your hardware concurrency level? And it'll tell me, and then I could basically create one for every core, essentially. So the work that we need to do is actually right there. Our task, we pop one off into a unique pointer. We check it to see whether or not we have one, because the pop can return nothing, which says that there's nothing in the queue. Then we run it. If it completes, then we just go through and everything cleans itself up. The task can have overwritten delete operators that will dump its memory back into a memory pool for game optimizations, or it'll just go out of scope and be deleted by default. Then, if we didn't complete, then it pushes it back onto the same queue and says, hey, you need to rerun me. So this is essentially our flow. And some of you will recognize this. And one of you in here will remember it from earlier when he actually said what this is. So to eliminate some contention, I'm essentially pulling off the front, trying to process it, and then if I need to, I push it back onto the back end, which is a ring. And luckily, we have some folks that are sponsoring a standardization of a ring, buffer, queue, something. It's a ring. But essentially, we can create this loop, and we can eliminate some contention things. So I'm waiting for that before I actually use it in my thing. But this is what I got so far. So this is my, yes?
I was wondering if you could actually take the several different queues and just basically use those queues so that if you have different types of tasks, or kind of say, if you have different types of tasks, some can only run on a GPU, some can run on a GPU or CPU, and some can kind of only run on a CPU, to kind of keep those separate, but feed your different types of hardware threads with the different types of tasks that they can perform.
Okay, so the question is, in summary, is essentially task specialization and thread specialization. This is currently focused on super generic, but yes, there can be things set up in your queue to where it knows what type of task it is, and it will properly assign it to the correct thread. This is a more super simplistic, generic setup where you just have a whole bunch of threads and throw at it, and then it will do things. For the things that deal with GPUs directly, this does not go into that because the threads that we're using in the standard don't actually operate on the GPU. There is some other work that's being done that's coming into the standard, hopefully, that is OpenMP has a GPU kind of implementation, as well as C++AMP, and there's a couple other research papers based on this. So having multi-threaded GPUs is going to be super awesome. I can't wait until I can render to one texture over here, render to one texture over here, and then do a merge operation before I actually display to the screen. That'll be super useful and super fast. But at this point, it's not in the standard. So this was very focused on what's in the standard right now. So this is my frame. These are the sub boxes are actually sub parts of my frame, each stage of the game, or each stage of the frame. I have a beginning, I have a pre-simulation step, I have a simulation step, I have a pre-visualization step, and then I have a visualization step, and then I have an end. So where are my synchronization points? Any guesses? So I have after simulation, essentially in the pre-visualization step. Anyone else? Yes?
Could you say probably by the end you need everything done at the end to kind of render the frame?
Okay, so you're saying before the visualization step, like at the end of the previs.
After the visualization.
Oh, at the end of the frame completely.
Right.
Okay. So these are my locations where I synchronize. And I only synchronize the beginning and the end because I have my stuff set up to where I can run multiple frames at once. So I can start one frame, start it going, then start another frame, and it'll tail behind using the state that was kind of stored globally as a way to continue and process more things. The pre-simulation step is actually the main workhorse. That's where most of the things get evaluated. The pre-visualization step is not as much the synchronization that you would think, because essentially all it's doing is coming up with the list of things to render and sorting those lists. So it's a lot of sorting and things like that, which can be compartmentalized and then parallelized. So these are the things that allow us to do mass parallelization. The beginning and ending are very small. They're not super big, so there isn't really parallelization there. The other things are much bigger and can fan out to a lot more things. If you're processing a lot of AI, then you can simulate a lot more AI, or you can simulate your physics state in there and things like that. So why doesn't Visualize use that? And that's part of the part that I already ruined, which is there isn't really any multi-threaded graphics rendering at the moment. It's very state-centric. So you'll say begin render, and you start doing all your things, setting up your render targets and things like that, and then publish to that, and then you end render. And so there isn't really that multi-threaded support at the moment. Like I said, CppAMP and OpenMP have like some GPU implementations that may help with that, but right now that's not in the standard. Yes?
I was also saying that isn't Vulkan and DirectX 3D or DirectX 12 also having certain, like they've gotten rid of the state structure and gone more with stateless structure.
So the question is about the new APIs, the graphics APIs about Vulkan and DirectX 12. So those are very new, and that's the key word. They're new, which means that the user base that you have millions of players playing aren't necessarily on them all yet, because we still have to support the guy that's using Windows XP. So some of those things are coming, and they're going to be available. And I believe NVIDIA has some cool tech where they're actually doing the multi-rendering thing that I was talking about, multiple render targets at the same time. But that's not in common hands. You may have someone who has that card and they spend a lot of money on that video card, but it's not necessarily in the breadth of people's hands. So some things like SIMD are on their way. There's some good papers on that to try and leverage some of the single instruction with multiple data pieces, which is great. and visualize fancy features can be pretty expensive. So isolating all that in the pre-visualization step where you sort everything and get everything ready and load all the data and stuff like that can be super parallelized, but then the actual implementation of rendering it and all that is very state-centric and kind of serialized at the moment. So some standard highlights, some things that I found that were in the standard that are pretty cool. So move semantics are great. I'm sure that everyone loves them. The threading library is new. It's pretty neat. The algorithms library is underused in games. We have a lot of those algorithms that we've implemented ourselves based off of the 98 standard, which didn't have some of them. But now, use them. You don't have to use the standard containers to actually run the algorithms. They run on concurrent or contiguous memory. So you can give it just an array, and it will iterate through the array because it knows how to step into the next element of the array. And so that means that there's a lot of stuff that's opened up right now that we can then use. The other thing there, the interesting little standard distance thing was something that I found by accident. But that thing actually does the pointer math for you on an array to figure out what index you are, which is kind of a neat little feature that I found kind of buried somewhere. Yes?
Yeah, actually the STD distance doesn't really care about the array. It actually cares that you have an iterator defined for it, so you could work on a list or a forward list as well.
So I haven't tried that. So his comment was that you can use the standard distance on a list or a forward list. I haven't tried that based on when I was using it in the contiguous array setup. It got me what I needed, and the things that I was using were contiguous arrays. So I haven't tried it with that. I'm sure that it does. It's just using the iterator stuff to figure out the distance. But I'm sure that the contiguous array is much faster than the running through the list of linked lists.
Oh, I'll agree with you on that. I just wanted to make a slight caveat that the STD distance actually only really what works is it computes the distance between two iterators, not necessarily 2 points in the array. So as long as it's a contiguous array, it will be fast. If it's a linked list or something, it will try to figure out how many steps it goes through to get to from X.
Okay. So basically summarized for the recording and for posterity, it's essentially standard distance uses the iterator to figure out what your actual index would be. So you can use it with the iterator classes like linked lists and other things like that. So other things. Standard function is a great use of a delegate. Lambdas are potentially even better with new complex lambda or more advanced lambdas and things like that. Then you can leverage that more. Static assert I found very useful. It allowed me to verify things in my const expr. Const expr is very useful as exampled earlier. A tuple can be great for dynamic data grouping. So if you're doing some AI calculations and you need certain attributes, you can isolate those into a tuple and then send that off to a task to be processed by itself in isolation. Atomics are great as it allows you to do things that ensure that your data that you're setting is actually understood by all of the threads because all of the threads get the same data piece. Standard array is a nice little thing. It wraps kind of a regular raw array, and it has all the iterators and things like that. Unordered map and ordered set are nice. They're essentially hash tables. They allow you to create your own hash functions, which is great. So you can hash your data off of specific things that you want instead of just giving it a data piece that it then has to do a comparison on. So what can hold something bigger than itself and ensure proper cleanup? So I have a smart pointer over here, and you are a smart man. So smart pointers are very useful. So I'm using them and leveraging them for data management, but not everywhere. So my rule of thumb within my project was essentially unique pointers were a way to show how you're supposed to use things in smart pointers as well, or shared pointers as well. But the usages of them were more along the lines of I wanted to actually change ownership of something, and I would use a unique pointer. If I wanted to actually really keep a ref count, then I would use a shared pointer. But I didn't use them everywhere. I still have raw pointers everywhere to process data because some things didn't need to know that they were an owner or not an owner. They just basically operated on something. So there is something in the standard that's called weak pointer, which allows you to check whether or not it's been deleted, and it creates a kind of a link back to a shared pointer. I didn't really leverage that. I found that using the weak pointer kind of seemed to me to add a little extra thinking that I didn't want to do, because typically if you have a pointer that goes away, then you actually want to crash there, and so fail early and fail correctly by crashing the code in the place where it actually happened. Yes?
Yeah, I just wanted to also mention that there is also another thing called the observer pointer that's coming up with C++.
Right, so that was something else that was going to be mentioned later. But the observer pointer is something that is coming up, which will allow you to mark something as not owning and operate on it. Right now, we're just using the raw pointers, and as Bjarne said last year, or somebody said last, maybe it was Herb, gave a talk about that he wasn't trying to get you to replace all of your stuff with smart pointers, and you can use the star pointer, but you need to use your smart pointers effectively. All right, so another one. I'm in front of you. You cannot see me, but you may see me later. All right, so we got some smart people in here. Now we got some future. So future is a really neat concurrency item that I'm sure that you've had talks about here and better talks about in previous times or even here. And so this is very quick. I'm using it as a tool to get information from the task. So I'm sending off a task, and then it's filling a future for me, and then based on that future result, I'm doing stuff. Futures are relatively small. They are essentially equivalent to 2 pointers. But you do have to be aware that future bool is the same size as future int pointer. So take that as you will. So another code block. So this is the pre-simulate part. And this looks really difficult, but essentially what I'm doing is right here, I have created a task, and I say, hey, task, I care about your results. So I'm going to have a future that's in my task that says, hey, I'm going to watch your results. Then down here, I'm going to say, hey, every time I run, have those results been given to me yet? No? Okay, well, I just won't worry about that for now. And then it goes off and executes other things on that thread. And then I have this function, which leverages the valid thing that's built into the standard, and then a Microsoft-only implementation of isReady. That may also be on Mac, I don't know, but for right now, the Microsoft implementation is not standard, but I found that if I just check it for it's valid or not, that doesn't mean that the data is ready to be grabbed. And valid will return you whether or not it has state. That's what it does. So it doesn't necessarily give you whether or not the value has been set. So this is ready. It tells you, hey, a value has been set. It is now time for you to get this result. All right. So what is infinite in size, but you never seem to have enough of? What was that? No. So time. So this one hasn't gotten a whole lot of love, but this may be the greatest contribution to the standard to games for now. This library for timing is something that will enable people to get resolution on their timing structures without having to go and jump through all the hoops or know these really fancy techniques. So who's in here has implemented the query performance counter? Who uses time get time? Who knows all the differences between them? There's 2 of you. So you 2, I'm going to start a company with. The rest of you, go back to school. So those 2 implementations are used for different things, and yet they give you similar type information. They give you what's supposed to be time. So Chrono wraps all that stuff into a simple interface. It allows you to it allows for type checking, and it allows you to use different varyings of times. So they have three current timers: a steady clock, a system clock, and then the high resolution clock. Yes?
Actually, I think I was at Howard's speech, and he said that there's really only 2 timers, and the high resolution clock is whatever the implementation decides for that high resolution.
Right. So the comment is that there's only 2 clocks, and the high resolution clock is whatever is implemented. That is true for Windows. Right now, Windows uses the steady clock as its high performance clock. But the idea is that you have 3 options. And if the implementer of the code says, well, actually, I have this other fast way to do it for the high resolution clock, they can change it. So that's why there's 3. So for here, we have this conundrum. We have an unsigned int that we're calling timestamp. What is it? Is it milliseconds, seconds, nanoseconds? And if it is an actual timestamp, what epoch is it? Is it the beginning of time? Is it UTC? Is it West Coast Pacific time? Is it Australian time? So there's been a lot of bugs where you don't know. And then we have another one, which is, all right, time in seconds. That's better. We know it's seconds. But then we can do assignments like that. I have 1,000. 1,000 of what? Is that 1,000 milliseconds? Is that 1,000 seconds? Now, the standard does have kind of, they do allow PostScript things where you can do MS or S on things to give it kind of a type. But that doesn't help you if you don't have a typed variable that you're putting it in. Yes?
Are you talking about user-defined operators?
Yeah, you can have literal where you can say 1 S and the compiler interprets it as 1 second. So this is some examples of that. So we have here a high resolution clock is what I'm using. The very top one is actually my time step for my simulation loop. And what I'm doing there is essentially extracting the difference in time from the last time I grabbed it and then making sure that I only do a minimum of 15 milliseconds. And that's great. I have all these types there. I can see what I'm doing. And then I can do stuff like the next example, which is I have 1 second, and then I can convert those things. It can be printed out as 1 second, 1,000 milliseconds, or even more nanoseconds. Then I do things like, all right, so I can add things. But it's really cool in that the compiler tells you when you add wrong. So the top one is adding 500 milliseconds to a second, and it produces milliseconds. And then you can see that it actually will display the information that you need. Then on the bottom one, I have a compiler telling me my types don't match because you can't add milliseconds to seconds and have it result in a second. So that's very useful. That catches bugs that would normally get into the code. So some of you may be thinking about the standard and say, what about async? Why aren't you using async? Well, async has a little bit more Wild West nature to it. It can spin up its own thread. It can run on the same thread. And there's a lot less control. So for this, I wasn't as keen to use async as opposed to my own thread queue and using a thread pool. And typically, you would use if you're on a Xbox or you're on a PS4, you would use a thread pool anyway. So I implemented it based on that. So these are things that are on the way. The file system library was experimental, but is now coming in as part of C++17. The one caveat with that is that it uses exceptions. So games are stuck at the moment until we get the lightweight exceptions in. Variant, which is really, really neat. We have the ability there to essentially use it as a state machine. So you can go and say, all right, if I'm doing a network library, you can say, okay, what state am I in? Am I connecting or whatever? And you can iterate through this variant to do different implementation, different things on the same data piece, which is great. So I found out today, which maybe I should pay attention more and stop looking down all the time. But the atomic smart pointers are actually made it in for C++17, which is really cool. I'm looking forward to that. Then we have C++ standard optional, which is really cool for dealing with a lot of things that we use sentinel values for. So the brief code example there is essentially we have a bool value that says whether or not something was triggered. And then we have a unique pointer to say, hey, this is the result. So now that just becomes optional, my result. And then if it has data, then it becomes, yeah, it was set, or it was triggered. And then there's other various refinements. There's refinements to the CONT expra, It allows for more complex functions as opposed to what it is now. We also have things to lambda, which allows for greater flexibility there. And there's plenty of other things that would take up more and more time for a talk. Yes?
Just curious. I was thinking that the STD optional, I think it actually take a little bit more room than just using the smart pointer and just testing it against whether you get a null pointer on that smart pointer?
So the implementation that I looked at, it doesn't take the data type and determine something about the data type. What it does is it essentially has the sentinel value built into it. So it essentially has a bit or a byte that tells it like yes or no whether or not it's set. So it's not actually checking the unique pointer for whether or not it's null or not.
Okay. No, I was just saying that if you set it, you default set it to null pointer, and if you do have a value.
Well, the construction of that unique pointer initializes it to null already.
Okay.
So then you would, once it gets constructed, it would be null, and then you assign it again, and then you'd have data there.
Yeah, I think that from my point of view, as long as you have a default constructor, having the optional and the sentinel value together might be fine.
Sure. So essentially, what you're indicating is that because I used a pointer, which was probably a bad example for this, you could just check the pointer if it's null or not, and that would be your sentinel value. So that is true if you're using pointers. If you're not using pointers and you're using a data structure or you're waiting on some result that's supposed to be filled into some piece of memory, then you would use a sentinel value. But this was a simple example with kind of a more common use is that pointer value. So some things that it would be nice to have. So a pool structure would be great. So you can pre-allocate a bunch of things and be able to pull things off of it. Right now, that's, as far as I know, the standard is kind of a little bit more like, hey, you know what, that's something that you can implement on top of our data structures. So they may not necessarily be looking at that. A pure keyword, I've written a lot of interfaces that are pure virtual, and I keep writing virtual function definition equals 0, and I get tired of typing virtual. So saying pure would be much quicker in typing. There is a proposal out there now for essentially using the attributes to identify things as pure. I haven't read it completely 100%, but it's essentially the crux of the idea, is they want a way to specify something as a pure virtual function without having to type virtual equals 0 all the time. There's a network lib that's out there. It did not get accepted for C++ 17. Hopefully it'll get C++ 20. The idea there is that library would provide basic interfaces for TCP as well as UDP. You wouldn't necessarily use that for some of the game implementations, but you can use it for tooling and other types of things that would be helpful. And with iteration, it may become the de facto starting point for games. Some other things. So standard thread is neat, but it doesn't allow for all the things that you would like. So you really can't set the affinity of the thread, and you can't set a name for it, which kind of is troubling for debugging. The affinity you can set by extracting you can get out the actual handle to the OS-specific object and then perform OS-specific operations to set the affinity or set the name, but that's still not as standardy as we would like. The future is ready. As I showed in my example, the valid was kind of not really showing me what I expected. I expected it to tell me when the value was set and it was ready to be pulled. But it didn't end up that way. It basically just told me whether or not the future had some sort of state. And so the isReady thing has been proposed by Microsoft as part of a try and get it into the standard thing. I'm not exactly sure where that is in the process, but it'd be kind of cool to have that. So one of the things that I was hoping to leverage a lot of was this CONT thing. And I ran into a thing where it wasn't actually executing at the time when I thought it was. So in the top example, we have a const int, and we actually are calling a const function with a const string, and it doesn't get executed at compile time, it gets executed at runtime. At compile time, the second one there gets run because the value that you're assigning to it is a const And that was a little bit disappointing to me. What I would have really liked to for it to have done is the compiler actually run the constexpr hash generation and then just stick it in there as a const value, which is what the macro evaluation stuff can do. So I was hoping for that. It didn't do that, but I don't know if that's necessarily in anyone's papers or anything. Yes?
I think they say that the constexpr, unless you specifically say that it's a constant expression, that it actually, because it's supposed to run at either compile time or runtime, that you can actually do that.
So the comment is that it can actually work. That's not the way that it worked in my tests. So every time I would iterate through there and I would be debugging, it would launch the constexpr function when and call there and iterate through there, which I didn't want to do. So you're commenting on my example. Yes. So my example of a const int is, yes, if you have a constexpr in front of it, then it can execute that. But the way that I was trying to use it was that in an if statement, I was trying to use it as a messaging item where I could use English messages or text messages and have it actually evaluate to a constexpr hash that then I could compare against a variable in my code. And then I could say like whether or not they were equal and then execute some sort of code path. So it's not necessarily that I was using a const int and it wouldn't evaluate. It was that the way that I was trying to anticipate that it would work, it didn't work that way. All right, so the final thing for nice things to have is smart pointers that can handle default destruction. So I ran into this and I was kind of surprised that this didn't work. But if you have a class that you implement in a header and CPP off to the side, and then you have a interface class that has a unique pointer to your implementation class, but that's not including your class name.h, then it will fail to compile unless you create a destructor in your containing class in its compile object. That, at that point, it can figure out what the class name.h is because you've included it into the CPP as you're trying to use it, things like that. So I was kind of surprised that this didn't work. It made it kind of weird because if you're using this unique pointers and shared pointers all over the place, then typically you would think that you can get rid of the destructors because all of that's taken care of for you. But unfortunately, that didn't work out. So I don't know if this is on anyone's radar at all. Yes?
Just was wondering, is this implementation specific or is this in general on all compilers?
So right now, the only compiler that I used, so this was a question about whether or not this was implementation specific. The compiler that I used was the Microsoft compiler. And for Visual Studio 2015 with all of the updates that I could get to try and leverage as many features as I could. So this may be a Microsoft only thing, but for games, it doesn't matter because we are held back by the system that doesn't support the thing that we want to use. So if Xcode doesn't support this or does support this and Microsoft doesn't, then we need to implement it for the way that the non-compiling compiler does it. Otherwise, we can't compile for Windows or we can't compile for Xcode.
No, the reason why I was suggesting that is that it may be a bug report that you might want to submit to Microsoft. I would say that you can use the current code generation just to see if it's really if it's a Microsoft feature or if it's not.
Sure. So I guess he's trying to get me to submit a bug, and I may do that actually, because this is something that I thought would work, and it would be really cool if it worked. So I know you can't write all these down, but these are some great talks by a lot of people that inspired me to do this thing and put myself out here. So I'm grateful for all of them. If you can see any of them and you like games, then go look up at the one by Naughty Dog. What they did was they ported their engine from PS3 to PS4, and they leveraged a lot of the techniques that I was using as well. Not necessarily C++11, but they were using a thing called fibers to do mass parallelization for The Last of Us. And so, do we have any questions? Yes?
I think you're talking about rendering more than one frame at once, or like
Not rendering, but processing one frame at once. I mean, because of the way that the graphics card is implemented and not having the parallelized like GPUs, you're not able to necessarily render at the same time unless you use a third-party thing that enables that behavior for you.
I was curious, I mean, would the work for the other frames depend on the user inputs?
So the question is about the work for previous frames that are, so if my frame is operating and then I go to a new frame and then I'm operating there, essentially what you get is you get a place where you're processing the data, and if the state of the data is not fully updated because the new frame is moving, then you'll catch it next time. And because the frames are operating at 16 milliseconds, the user's really going to have to do something to their machine to slow it down to actually see that hitching, the delay in it. So I think the session is over. If you have any questions, please come up. I love talking about this kind of stuff. And I believe it's the end of the day, so come up and I'll have till I fall asleep.